introductions are kind of in order. As Lee said, I'm head of product at Bibblio. I'll get to Bibblio. As for myself, my background is in software development. I've been in programming for about 13 years now. About half of that time I've also done kind of active product development, and in the two. I've kind of gone pretty deep in my own time studying language and semantics and semiotics and mythology. I've written and published short fiction. So yeah, kind of weird, awkward introductions aside, that does inform a lot of what I'm going to be talking about tonight. You know, the topic is ostensibly how to manage data science at an organizational level, but what I'm very interested in is the kind of systems of meaning that we create in groups. You know, we sort of co-create these things and then promptly just take them for granted and completely forget about them. And stuff like process and best practice language, these things shape our world quite significantly. And I think it's worth paying attention to those and being quite purposeful about how we do things like manage team processes. So like I said, I work for a company called Bibblio. What we do is essentially content recommendation as a service for digital publishers. So it's machine learning and also not machine learning algorithms that basically provide kind of end-user content recommendations on the page for digital publishers. And we kind of render the recommendations in place visually as well as sort of via an API. But it's not ad-served, it's all done in the interest of the publisher themselves. So it's not yield optimized, it's very much about the best possible kind of exploration journey for the user possible. And yeah, like I said, I'm head of product there, but because I have a strong kind of technical background, I do a lot of architecture and the way we write the user stories. I work very closely with the inimitable Dr. Mahbub, who's sitting over there, my colleague. So yeah, we kind of work together on data science. He teaches me quite a lot, and we try to kind of write the user stories in a way that isn't, it's a bit sensitive to how the tech might be implemented. So yeah, I'm going to start in kind of the darkest timeline and talk a little bit about some of the things that I think is wrong with the way we do stuff, and then I'm going to become increasingly positive and aspirational towards the end. So the first thing the two big things that I think are wrong with essentially Agile software development. You know, I'm not going to go too deep into Agile itself, but I think there are two fundamental issues in it. It does a lot of wonderful things, and I think it's a very good thing for the software industry. But two things it doesn't do very well is sympathy and balance. So what I mean with that, non-technical contributors are not really represented in Agile software development practice, not very well anyway. If you look at Agile, just sort of a very quick run through, you know, it's create user stories, backlog, sprints, story points, cadence, velocity, all of that stuff. Now, create user stories backlog, I mean, that's somebody's world. That's an entire thing that's just absent from our process language. So it's very much centered on the software developer. It's all about keeping them happy, and it's all about keeping them productive and making sure that they have everything that they need in order to do what they need to do. That obviously leads to an imbalance. And that kind of makes sense. You know, software development is expensive, and it has a very high potential for return on investment. So it makes sense that we would structure our processes around optimizing that aspect of the problem. But it's a little unkind, in my opinion. It doesn't really treat everyone else in the system with a lot of respect. And then you get all of these kind of cliches, you know, software developers being kind of grumpy, surly, difficult people. I honestly think that's largely due to the process dynamics that we've kind of built ourselves by favoring these people too heavily. And I speak for myself too. I mean no offense with any of this. Like I said, this is the darkest timeline. It'll get better. So some things have changed recently, I think, that have kind of led to a need to rethink some of this stuff. Specifically, data science is one of them, because that function has a lot of the same properties. It's expensive, and it has high capacity for return. So now there's suddenly a new kid on the block that warrants the same kind of attention that we've given software developers in modeling process in the past. And I think that's cool, that's quite significant. But we're not there yet, I don't think. You know, the process is still very much centered around programmers. I think it still very much speaks the developer's language. You know, stuff like sprints, velocity, these things, they don't have analogs in data science. And nobody's really tried to adapt them to fit data science. or come up with a new best practice. The other thing I think that's happened is responsibility. We're increasingly kind of socially conscious around the impact of our work. Data science in particular, the bias of algorithms. There's a lot of interesting stuff going on around the responsibility we have to others in designing these systems. For me, a big thing that comes in here is this idea that we cannot hold all of the perspectives that we're accountable to. I'm a able-bodied, cisgendered, white male, like yet another one. I can't speak for everybody, it's not possible. So I think that's an important thing, and I think that's another part of the kind of the time we're in that warrants this change in our attention to process. So why should this kind of idea of systemic bias not apply within teams as well? Why aren't we looking at the people we spend most of our time with in the same life? So I think how a lot of this stuff manifests, this kind of process imbalance, is a problem of perspective. We tend to look at each other across a big divide, and we think of each other in terms of our own perspective. And especially within software development and data science, this can cause some friction. And I think that's unnecessary, right? So I'm going to caveat this a little bit and say this is maybe a little bit contentious or confrontational, and I don't mean it as such. I think all of this stuff is very valid, but there's one problem with it that I'll get to at the end. So from the perspective of data science, not yet perspective. So let's just describe software development and data science in terms of how they're a little bit different to each other. Software development is kind of focused on design decisions. I think that's very significant. I think it falls more broadly within the remit of design. I think it's less engineering than we like to advertise it is. I think it's actually got a lot of kind of softer skills. It's a much softer skill than advertising. I think. It's a lot about linguistics and about expressing ideas and expressing intent. And as such, it's quite subtle and very difficult to impart. When you talk to somebody about a piece of code and you want to tell them that it's not good or it can be improved because it doesn't encapsulate correctly around a certain idea, it's a subtle thing. You can't quantify that. It's a broad, fuzzy sort of space. Data science, in contrast, is rooted in mathematics. It's very formal. It's very exacting. You can't make mistakes. You need to think very clearly about what you're doing, which is a very different thing to this kind of soft skill of software development. And it's also difficult to impart, but for a very different reason. It's very complex. You need to have a very strong foundation in what you're thinking about. Your ideas need to be backed up by peer review, like for a start. So they're very, very different. Then we get to the problem of perception. Right? As a result, software development, as seen from the perspective of a data scientist, I would imagine, I'm not a data scientist, so please correct me if I'm wrong here, but software development, you could say it kind of lacks rigor and theoretical foundations. It's very unspecific and kind of broad and fuzzy and very hand-wavy. We talk about design patterns and shapes of code, and, expression of intent, and these are not exact things. They're very interpretive. On the flip side, data science doesn't have a lot of structure, and it doesn't really kind of encapsulate ideas very effectively. It reads very linearly and very imperatively. So if you're looking at it from like a software design perspective, it's quite hard to get your head around because it just lacks a whole lot of established ideas around how code should be structured. I caveated a little bit early. These things are valid. The only problem is that they're one-sided. We're looking from our own perspective across a big divide at somebody else and expecting them to be like we are. And I think that's wrong. I really don't think there's value in doing that. So this is, I think, the problem that we face. I think this is the kind of context that we're in when we're designing process for data science. It's like the system as it stands today broadly is not in our favor. We don't have prior art around how to do this because that's all structured around software development, which doesn't include data science. We'll get a little bit more practical now. Our process at Bibblio, I'll kind of delineate a little bit, just talk about some of the steps that we do when designing algorithms. But very importantly, they're designed not for the strength of that process. The sequence of steps is not what's important. That's worked for us.
the important thing, I think, is the modes of thought that they embrace. So each step really talks about a transition between two types of thinking. So we'll start with the process itself. The first one is you start with an incentive phase. I think that's incredibly important, and I think we often neglect that in everyday problem solving, in fact. We tend to think primarily in terms of solutions, and I think we do ourselves a great disservice by not taking the time to form a strong model of intent. So when we're trying to solve something that we find difficult, I mean, I speak for myself here and just my own observations. I think this isn't unequivocally true, but I've noticed that we tend to go straight to a solution for a problem that we scarcely understand. We don't take the time to listen to the problem itself, really kind of get our heads into what it is that we want to be different about a situation. So I think formally modeling this in a process is very important, to think about what you're trying to achieve. The next thing is then R&D. For us, that means catching up on literature, doing a lot of review of literature, reading. Coming up with a kind of a short list of candidates, looking into the viability of those candidates, building prototypes of those candidates. And then kind of evaluating that in some form or another. You know, that this is a bit kind of intuitive. It's a bit difficult to quantify at this point because you just got to take a best guess of what you're going to spend some effort building before you evaluate. Once you've kind of chosen some things to actually implement, then it becomes kind of a product development space, you know, where it gets cut up into user stories, and you kind of build that on the backlog, and software development kind of gets involved. It really just sort of seeds the backlog at that point. And then implementation is actually building that, executing those stories. And then testing is where we sort of see if it's working. You know? So if ideally you kind of do A/B testing, where you've built a few of them and you kind of evaluate them against each other. Not always easy to do in practice. You know, sometimes you have to do that as part of R&D and actually just get internal stakeholders to kind of evaluate, to do blind evaluation of your candidates. And that's kind of it for us in terms of process. I'm kind of going through this a little bit quickly because, like I said, the important part for me is the modes of thought. When you're talking about incentive, you're talking about what the product should be and how data science can help. So this idea of transitioning from a product mindset to a data science mindset. How can you get somebody with a different perspective involved to take over the problem from you? Because that's essentially what a process is, right? If it's a multi-agent process, it's all about collaboration. It's all about how people can kind of get each other's ideas, pick up on them, and improve them. So we should really be thinking about that transition. You know, it's really not about solidarity. It's not about individualism. It's not about taking something and really owning it and like really nailing it and just knocking it up the park. There's all of this language that we use all the time. I think it's quite wrong. It's for me, it's very much about how can I have my ideas and give them to you so that you can take them and make them better. So for me, the incentive phase is about product and data science sitting together and talking about the problems they're trying to solve and trying to understand that problem. Come to kind of a unified language that expresses the intent, not just the solution. Data science then kind of takes that idea, does R&D, and there's quite a big, deep process in there that I think I'm not the best person in the room to speak about because I couldn't tell you guys how to do your job. But the end result for me is getting it back to product. So going from a model of intent to a design space that could solve that problem. So then you're talking about things like specific candidate algorithms, like what their strengths and weaknesses are, what their anticipated performance might be, like how they might fit into the stack, like what are the technical constraints, what kind of data they're going to require. And then it becomes a product design problem again. Now you have the constituent parts of a solution, and you need to kind of think about how they're going to fit together and become something, a product. From there, we're kind of back in like more familiar territory, you know, products to software development. So that's just backlogs, user stories. You know, this is the stuff we know quite well. Still, I think, underrepresented in Agile best practice, but nonetheless, it's a normal thing. And then implementation is sort of from software development back to product. Testing is from product to customers. So this idea of mindset boundaries or mindset transitions, to me, is what process is all about. You know, if that works for us, and you're welcome to try that, and I think it's a good approach. But I would really encourage you to think not of it as a playbook. it's not about that. It's really about taking this idea of people having to kind of share ideas and pick up on each other's ideas and improve those ideas. That's the important part for me. The next thing I think that's very difficult to do is cadence. This is way more practical. If you imagine sort of software development as like a little cog that kind of spins, you know, the sprint cycle. One of the criticisms of Agile development is it makes software developers feel like hamsters. They just sit in this wheel and it spins like every 2 weeks. It just starts again and again and again and again. So the cog analogy kind of works there. Data science is very different. It's got a much longer cycle. You know, if we look the thing that I just described over there, you know, incentive R&D sort of through to product development, that takes time. That's not a 2-week sprint. You need to give people space to sort of sit in these problems and think about them. You know? If you're going to take the time to form a model of your intent, I mean, that alone doesn't fit into a sprint cycle. You know? So cadence is very different. You know, I like this analogy of these gears because data science, I think, is a much bigger cog. Not bigger in terms of importance. It's just a slower turning. It's got more inertia. You know, it's a bigger thing to move. And yet we try and cut it up as if it's software development. We try and fit it into this 2-week cadence thing. Cut it down into 3-point user stories. It doesn't make sense, really. Another challenge, I think, is the interface points. You know, so in that process I just described, there's only really like one step where the product development artifacts become software development artifacts. And that's why there's only some teeth on one side of the gear. Because this one's going to turn for a very long time, quietly, happily, all on its own, without these people knowing anything about it. And they're going to need to keep working on the API and the front end, and they're just going to need to keep spinning and keep spinning. But at some point, these gears are going to touch, they're going to connect. And then this thing's going to spin really hard, and on nothing else for quite some time. And that makes planning incredibly difficult. You kind of have this problem. I reread Dune recently, you know, plans within plans within plans. And it's backlogs within backlogs within backlogs, you know, because you're creating a data science backlog that's big, chunky, sort of meaty stories that take a very long time to execute. And then you've got your sort of software development backlog kind of running along. But every now and then, one of these stories is going to become 7 stories there. And it's going to feed this wheel like really, really, really fast. And if you want everybody to kind of stay in sync, it's just difficult planning. You know, like there's no silver bullet to this. Your product developers have a challenge when you're working with data science. And it's got nothing to do with either party. It's just the fact that they're very different. And they've got very different needs and very different like life cycles. You know? So yeah, I'm afraid I don't really have like a solution to this. It's just something to be aware of. Like you need to think about how data science is going to stay productive in the long run. A good thing there is having R&D tasks that are far in the future as backup whenever they have downtime. They need to be investigating, they need to be reading, they need to be doing literature review. Sort of at all times, the future has to be visible. And then there's very specific moments where they're kind of on hand very immediately to deal with the developers actually implementing stuff. And it's just difficult to manage, I think. Now, there's a problem with this analogy. It treats everything as a production line. We're looking at all of this as a linear flow of artifacts from one person to another, eventually to a customer. And it doesn't really model the problem very well. We come back to this idea of modes of thought. In reality, this segregation doesn't really work. It's not like these people don't ever have to speak until these gears touch each other. It doesn't work like that. It's more like this kind of an image, you know, where at the beginning of your R&D cycle, you're quite isolated as a data scientist. You can work on stuff quite on your own steam. You've got a clear sense of what you need to achieve. The stuff you're working with is very investigative. And as you become concrete about your solutions, then the stack starts to matter. Like what software has already been built, what's the skill level of the team, like what kind of data is available. These questions start to come in, and they fall increasingly in the remit of software development. So by the end of the delivery cycle, it's almost entirely software development and almost no data science. And data science kind of falls back into a supporting role. So this idea of modes of thought and transitions, I think, is incredibly important throughout this thing. You know, and again, there are no silver bullets to this. There's no solution as such. Some tips I would advise is like have regular meetings. You know, have
have a cadence set up every 2 weeks or every week where people can just discuss what they need to discuss. And if that meeting is, hey, how are you? Everybody's good, nothing to talk about, nice to speak to you today, over, that's cool. But keep the meeting in the calendar, because other days it's going to explode. You're going to have so much stuff to figure out. And yeah, I mean, beyond that, you just a bit of sensitivity, understand that you need each other throughout this process. Be sensitive to each other's time, don't just slack demand right now, answer my question. Kind of do a little bit of kind of planning with each other and say, hey, I'm going to need some of your time later this afternoon because I'm working on this, and it's important to you because you're going to have to work on it afterwards, So it's a bit of a fuzzy thing, but I think it's really worth flipping this whole idea of the production line on its head and thinking of it again as transitions of mindset. Like, how can we work together to solve problems that any of us as individuals would struggle to accomplish? Now, for me, this stuff is the heart of it all, actually. This idea of kind of like blending modes of thought. Andrew challenged us earlier to kind of share our superpowers, and I think that was really, really a cool way of saying it, because for me this is a really good analogy. Having a superpower, if you look at kind of movies and just the canon of literature we have, most often the superhero's strength is also their weakness. So like Iron Man is a cool example. His strength is that he's a billionaire genius. And his weakness is that he's a billionaire genius. He's arrogant and cocky, and he doesn't care about other people. And invariably, if you look at that kind of Greek cycle of the story structure, the ordeal, the climax of the second act, is some form of recognition that I'm not in this alone, that I need other people, and I've treated them badly, and now they're not around anymore. So this idea of superpowers is very important to me. Like, data science is a superpower, and it's also a weakness. The same, back to my earlier slide about stuff being fuzzy and hand-wavy within the realm of software development, and like imperative and exact and linear in data science. Neither of these things are bad for being true. They're only bad if you expect other people to be like you. If you can find a way to leverage each other's strengths, then broad abstraction and clean coherence to formalized models together is an incredibly powerful combination. I mean, to make this a little bit more personal, like I tend towards the abstract. So I struggle with detail. I get bored with detail. So I need people around me who love detail and don't mind abstraction. And I need to understand that they love detail, and I can't get impatient with them, because otherwise I just push them away and I don't get this benefit. So I hope this kind of comes across throughout this process. I'm really just talking about this. That's all it's about. And just very quickly, kind of, don't have a lot of time left. This is not only about data science. Think of a sales function. Software developers and salespeople. Salespeople have a cadence too. They've got things they need to do. They've got a process. They know what they're doing. And yet, software developers tend to treat them like they don't. And they just, like, how many software developers have you met who know the average sales cycle of their sales team? How long does it take to acquire a customer? How many emails does it take? How much does the pressure ramp up throughout that process? At what point do they need to make specific commitments to what the product can do? We simply don't ask this of each other, and I really think we should. Funding rounds, same thing. I mean, if you're talking 2-3 years at a time, at the end of a funding round, technical debt is a very powerful thing. You should be spending on that technical debt credit card because you need to make proof points to get money to pay off that technical debt and keep going. But we don't talk about that. We talk about technical debt as if it's a bad thing, because from the perspective of a software developer, it is a bad thing. So this balance is incredibly important to me. And I think really if I was going to say anything at the end of this, it's just be kind to each other. Like, so much can be solved just by looking at one another and thinking about what the other person needs. We want these playbooks, like how do you manage data science at an organizational level? There's no answer. The answer is the people around you. You have to think and care about them, and it all becomes a lot easier if you do that. And yeah, if you have any questions, please get in touch. I don't have social stuff, but you can email me. If anyone has any questions, do we have time?
Yeah, sure.
Put your hand up if you want to ask a question. As MC, I'm going to exercise my privilege to ask the first question. We've all got that solutions architect that's pressing for us to ship. get that product out the door. How do you marry the tension of you're trying to hit deadlines, you're trying to ship products with some of the tensions you described?
Yeah, I mean that's the game. I think it helps to have somebody who's clearly in a mediative role. So like the head of product to me it's a very weird thing, like as a title, because it could mean I need to know exactly what the market is up to and what people want and exactly what product I need to design. And I trust my CEO for that. He knows that way better than I do because he's out there speaking to people. What I need to do is understand everybody in my team and know what they want and make clear and concrete expectations or set expectations inside the team. So if the solutions architect is wanting to get something out for this particular customer, I need to go to the dev team and spend some social capital with them and say, this needs to happen quickly, what can we sacrifice, please understand. But if I overplay that card, I have no social capital left to do that with. So it's a social role within the organization, I think, that just has to be, try to be balanced.
Before we put questions to the floor, hands up if you have product in your job title or description. Don't be shy.
Yeah, please, I'm feeling quite alone now.
Yeah. So, who has a question for Nick? You have a hand up. Yes.
Yes. Good question. Thank you. There are normally two other types of people who think differently. One is like sometimes they now call themselves design ops that deals with UI and UX because they are needed to help you in persuading the business. And then there's also the issue of how do you explain what you did with the data science? And then there's the question of what about dealing with bias, for example, where in certain locations, like in the US, there are certain data that if you use as is against the law.
Okay, cool. So bias, I think, is a topic unto itself. I think I'm not knowledgeable enough about systemic bias in algorithms to answer that question very clearly. I do think, though, that these same ideas help if you think about mindset transitions. Make sure that you're bouncing it across as many mindsets as possible, and you're likely to mitigate the cause of bias. Because bias is one person expecting the rest of the world to be like they are. A simplistic definition, but you know what I mean. So in that sense, this generally adopting these principles will help, but I don't think I can answer that question directly because I'm not a data scientist. The other questions you asked, design is harder than data science, in my opinion, to integrate into a team. Purely because the artifacts are very unique in nature. So design artifacts, I think similarly to how data science lacks a process language, design lacks a process language. It's got a very strong internal design language, but it doesn't have a language around interaction. So what is the artifact of design? Okay, cool, it's a Photoshop file, but like that's not useful to the other members in the team, and then there's invariably friction. The same way that you could kind of say the data scientists and developers see each other as either too like pedantic or too hand-wavy. Designers and developers haven't figured that out yet, I don't think. So same problem, but in my opinion, harder to solve. I've yet to see that work, I'm afraid. And your third question, I'm sorry, I don't know if I've answered that in what you said.
You have answered.
Okay.
Much appreciated.
Hi, so I'm in sales. What's one thing, aside from wanting things fast, develop faster, what's one thing that sales guys overlook or don't appreciate from a product perspective?
I mean, I feel kind of like corny just saying the same thing again, but it really does come down to it. Understanding the product development function is it really? If just a bit of empathy, which is kind of what I've been talking about throughout. If salespeople had a clearer sense of what the product does and what it takes to make that product do that thing, then they'll have their own intuition about what's reasonable to promise and not. I really don't believe in putting people in like strict rule sets that govern the way they can behave. I really think the best answers are in allowing people to be mature, self-directed individuals. And for that to work as autonomous agents, you need to understand one another. So then the onus is on the salesperson to get the product to function, And likewise, it's on the product function to communicate with the sales team and not just say no or yes, not just be this adversarial relationship, but be collaborative around it and talk about what the product might be able to do in that situation. Does that answer your question?
Yeah, I love that. Thank you.
Do you have any more questions? So, question for me, Nick. When you're working with an engaged team, a collaborative team is good. It's all healthy, but leadership is a powerful factor to a project success. What would you say are the elements of successful leadership in bridging the divide between the left and the right, the software dev and the data scientist?
This is it touches on a very fun idea for me. It's one of my kind of personal favorite mental models. I like to think of the strength of one's voice. We tend to assume that we are owed other people's attention, and I don't think that's necessarily true. We've got kind of old folk tales about this. The boy who cried wolf was a very good example of that. If you abuse your voice, I mentioned social capital with the dev team. If I overplay social capital with the dev team by just adhering to the implementation manager's needs all the time, I lose my strength of voice with the dev team because I'm not respecting them. And I think leadership is very much about having a strong voice, and that's not about stamping your feet and speaking loudly or kind of mansplaining your way through the situation. It's very much about respecting people and understanding how your words may impact them. And if you cultivate a strong voice, then deferral is also a strength. To say, I don't know this, why don't you listen to that person? That's leadership too. So it's not about having somebody say everything. It's about the right people being trusted. And that's very much a personal responsibility rather than an organizational structure.
Thank you, Nick.